the next thing they talk about here is the x-intercept method. I don't think I had ever seen this method until we started using this particular textbook. I don't have a lot of love for it. It works, but it seems like a lot of work for something that you could have solved maybe in a more basic way. But we'll look at least one example using that x-intercept method. So when we do this, the first thing we want to do is get our equation set equal to 0 using algebra. And then we want to rewrite it so that y equals h of x. The x coordinate of any x-intercept is the solution. All right, so job number 1, get everything set equal to 0 is our objective. So we're starting with negative 4x plus 9 equals 2 times x minus 2 plus 1. So that says negative 4x plus 9 equal, distribute, you get 2x minus 4 plus 1. So if we subtract the 2x from both sides and combine these like terms in the next step. So negative 4 and negative 2 puts me at negative 6x plus 9 equals negative 3. And then we can add that 3 to both sides. And you have negative 6x plus 12 equals 0. So we want to graph y equals negative 6x plus 12. The x-intercept, x value, will be our solution, okay? So if we're thinking about graphing this guy, so if we start at negative 12, positive 12, sorry, that'd be up here. Then we need to go down 6 and right 1, down 6 and right 1. There's our x-intercept point that we're interested in. So we're talking about this line coming through here like this. So that's telling me the intercept is over 2 and up 0. So x equals 2 is our solution. So again, yes, it's true. There's a process called finding the zeros. We talked a little bit about zeros earlier in the other chapter, chapter 1. It seems like it would have been easier just to solve it algebraically. This is them giving an attempt at something in a graphical approach as we look at this particular problem. Okay, so that's how we're solving that one. Approach, I realized I skipped a page here. Let's go back and get page number 4 as we're looking at this. So this is example 7. Sorry for those being a little out of order here. So when we use a graphical approach, normally when we talk about solving these equations graphically, we set the left-hand side equal to a y value, and then the right-hand side equal to a y value, and that x value of the point of intersection serves as our solution. So for this problem, we would have y equals 2x plus 1, which I'm going to graph in green, and we would have y equals x plus 2, which I'm going to graph in blue so that we can look for our solutions. All right, so in blue, we were doing y equals x plus 2. So that goes through the point 0, 2 with a slope of 1, which we could write as 1 over 1. So 0, 2 is here, up 1 and over 1, up 1 and over 1, up 1 and over 1, up 1 and over 1. So that blue line is going to run through here like this. We go through the point 0, 1, and our slope is 2, so 2 over 1. So 0, 1 is here, up 2 and over 1. Right there is that point of intersection we're going to be interested in. We could also go down 2 and left 1. So if we draw this line through here, it looks like this. So again, this point where they're both common is the point that I'm interested in. And the x value of that point, so that point's coordinate was over 1 and up 3. So that means our solution is going to be x equals 1. Whatever the x value is from where those 2 points cross, that is, there are two lines cross, the point where those two lines cross, that is going to be the solution to this equation. All right, then we already did number 8 here because I got out of order. And now we're going to go look at some information about percentages. So as we look at these percentages, what they put in writing here is a percentage can be written in percent form, which has the percent symbol after it, or in decimal form, which we'll use a little r for. To change percent form to decimal form, we divide by 100 or move the decimal 2 places to the left is what y'all typically remember. So what we're looking at here is 45% equals 0.45. 0.03% is 0.0003 as a decimal. 420% is 4.2 as a decimal. Negative 1.45 would be negative 0.0145 as a decimal. 2/5 is the same as 4/10, which would be the same as 0.4. So then that still has his percent symbol with it. All I was doing was getting that converted over to a decimal as far as 2/5 out of fraction form and into decimal form. But now I want it out of percent form into decimal form. So it would be 0.004 as we're looking at that. So quick, easy peasy. All we're doing there is dividing by 100, which is the same as moving the decimal 2 places to the left. And here says a survey found that 76% of bicycle riders do not wear helmets. Of is a mathematical word for implying multiply. Okay, when you see of, that almost always implies a multiplication. So find a formula f of x that computes the number of people who do not wear helmets among x riders. So f of x equals 76% is 0.76. Of means multiply by x. That's your whole function right there. F of x equals 0.76 times x. Of means multiply. In part B, it tells us that there are approximately 38.7 million riders who do not wear helmets. The number who do not wear helmets is our f of x. And so what we're saying here is our f of x equals 38.7 million. They want the total number of cyclists and that is our x value. So we're going to have to go through and solve for x. So 38.7 million is 76% of what number is what we're looking at here. So to solve this, we would divide both sides by 0.76. So we take out our handy dandy calculator and we put in 38.7 divided by 0.76 and we get back 0.5092. Let's go with that. 0.5092. 10526 is our x value. But remember, that's going to be in millions. So that is the same as, that means multiply by a million. So we've got to move that decimal 6 places, which would put us at 509,210.5, depending on how they ask you to round that. So 509,210 or 211. Again, just be careful you're reading about how they want you to actually answer that when we go through and put our answer in MyMathLab. 11, we're going to solve for a variable in a problem that has variables left in its final answer. So if we think about what we're trying to do here, we're trying to solve this for b. So the first thing I would probably do is multiply all the way through by 2 to get rid of that fraction. So on the left-hand side, I would have 2 2a equals the 2 and the 1/2 cancel out, and you're left with h times a plus b. Again, keeping in mind we're trying to get this b by itself, we could get rid of the h by dividing both sides by h. All right, so after we divide by h, we would have 2a over h equals a plus b. We're trying to get that b by itself, so we could subtract a from both sides. So our fraction is 2a over h. From that fraction, we're subtracting a. That would be our b value, and we are done. So 2a over h minus little a would be the b. Sometimes you guys let that stuff overwhelm you because there aren't any numbers, or you're not solving it for an exact number. You still follow the exact same algebraic steps. You're just leaving the letters in. All right. Problem solving. Read the problem, reread the problem, read it again, read it again, read it again. Make sure you have a feel for what that problem is looking for. Draw a picture or a table or a chart or whatever's appropriate for the problem type. Get an equation, solve the equation, check your answer, and state your answer. All right, so those are our problem solving steps as we proceed into some word problems here on page 7. A large pump can empty a tank in 5 hours. A smaller pump can empty the same tank in 9 hours. How long will it take the pumps if they work together? All right, so we typically go with an equation that looks like this. 1 over T1 times x plus 1 over T2 times x equals 1. So what are we talking about there? T1 is the time that one of the pumps can do it. T2 is the time that the other pump can do it. So each hour, they're doing 1/5 of the job for the big pump, 1/9 of the job for the small pump. The 1/5 of the jobs plus the 1/9 of the job have to add up to give me one whole job. And that's where that 1 is coming from. So for this problem, that would say 1 over 5 times x plus 1 over 9 times x equals 1. My least common denominator, 9 times 5 is 45, right? So I'm going to multiply that all the way through there, which would leave me with 9x plus 5x equals 45. 9 plus 5 is 14x equals 45. Divide both sides by 14, and we have x equals 45 divided by 14 is 3.2. And that was going to be measured in hours. That is how long it takes them if they work together. Now, does that answer seem reasonable? Well, the big guy could do it in 5 hours all by himself. So we better get an answer that's less than 5 if they throw somebody in to help him, right? And so 3.2 is less than 5. It seems reasonable that that would be our answer as we're looking at example 12. In 1 hour, an athlete traveled 10.1 miles by running the first at 8 miles per hour and then at 11 miles per hour. How long did the athlete run at each speed? So anytime I see stuff like this with speeds, the first thing that pops into my mind is distance equals rate times time. And so in this case, we have a couple of different rates. Part of the time they were running 8 miles per hour, and part of the time they were running 11 miles per hour. The distance traveled total was 10.1. And so we don't know. Oh, we got one more piece in here we need. Sorry, 1 hour. Total time was 1 hour. So if we call the time here x, okay, what you want to keep in mind is when I add together these columns, it has to give me 1. So that means this one must be 1 minus x. If you check, if I add line 1 to line 2, the x's drop out, I get 1, so that is our correct answer. Now that tells me that multiplying here, I don't want to use that color, that tells me that multiplying here would give me 8x, and multiplying here would be 11 times 1 minus x. And when I add these columns, we got to get that, or these rows, we need to get it to add up. So my equation becomes 8 times x plus 11 times 1 minus x gives me that total of 10.1. So that says 8x plus 11 minus 11x equals 10.1, doing the distribution. 8x minus 11x would put me at 3x, negative 3x, plus 11 equals 10.1. Subtract the 11 from both sides. We get negative 3x equals negative 0.9. Divide both sides by negative 3, and you get x equals 0.3. So if we think about that, that's going to be in hours. Probably you're not going to give your answer in hours here since it's 0.3. So if we take that times 60, that's going to give us our minutes. So 0.3 times 60 comes back at 18 minutes. And that was the time at 8 miles per hour. So now that means that if we drag this back over here, actually what we're going to drag back over there is the 0.3, right? So that was our x value. So 1 minus 0.3 is 0.7. 0.7 times 60 better come back at 42. Let's see, 0.7 times 60 comes back at 42 minutes. And that would have been at 11 miles per hour. So we knew that when we were working hours, the 0.7 and the 0.3 had to add up to give us this total of 1. If we switch it to minutes, we still need to be 1 hour. So 1 hour is 60 minutes, right? And if we check 18 plus 42 does in fact give us 60. So we can be confident that we have our correct answer. All right. Number 14 is a similar triangles question. It says a person 6 feet tall stands 17 feet from the base of a streetlight. If the person's shadow, it's spelled wrong, is 8 feet, estimate the height of the streetlight. And they were really nice to us. They gave us the picture here. So as we look at this picture, this triangle is one of the triangles that we're interested in. And this outside triangle is the second triangle. The height on that second triangle is what we're trying to find. So we can go height to length equals height times length. So our height is unknown, and the length of that green is going to be 17 plus 8. We set that equal to, the height on the blue is 6, and its length is 8. So h over 17 plus 8 would put me where? 25 equals 6 over 8. You actually could reduce that to 3 over 4 just to keep your numbers a little bit smaller. So we could multiply both sides by 4 and multiply both sides by 25. So that says that 4h equals 75. Then we could divide both sides by 4. H equals 75 divided by 4, which is 18.75. We were measuring our height in feet for the height of that street lamp. The application problem here says pure water is being added to 153 milliliters of a 30% solution of hydrochloric acid. How much water should be added to dilute the solution to a 13% mixture? All right, so here's what we're looking at. Pure water is 0% hydrochloric acid. So a bucket of that I'm adding to a bucket to end up with a final concoction. This bucket is at 0%. I'm adding that to a bucket of 30%, and I want my final bucket to be at 13%. I don't know how much water, that's actually what the question asked me, how much water should be added to 153 milliliters of 30%. Now, how do I know how much is in the end? Well, if I add these two things together, it's going to give me how much is in this bucket. So it's whatever my water is plus the 153 that was already there. So our formula becomes 0 times x plus 0.30 times 153 equals 0.13 times x plus 153. So 0 times x is just 0, plus 0.3 times 153 is 45.9, equals 0.13x plus, we distribute that 0.13 times 153, we get 19.89. All right, so we can subtract 19.89 from both sides, which is 45.9 minus 19.89, 26.01 equals 0.13x. Divide both sides by 0.13, and we get 200.08 as our x, and that would be our milliliters of pure water that we need to add to cut our 30% solution down to a 13% solution.